vast darkness of the universe, every star has a destiny. They are born from clouds of dust, live powerful and fiery lives, and eventually reach an end that seems inevitable. Some fade quietly into white dwarfs, some explode violently into supernovae, and some collapse into black holes that swallow even light itself. This cycle has always appeared universal, predictable, and unavoidable. But then scientists found something that changed everything we thought we knew. A group of stars that simply refuse to die. These stars break every rule we have about stellar evolution. They reach the point where they should collapse. They reach the point where gravity should crush them, tear them apart, or transform them into something entirely different. Yet nothing happens. They keep glowing, keep burning, and continue to exist far longer than any model says they should. It is as if the universe itself has granted them an extension, a loophole in the laws of physics, a strange permission to linger where others cannot. And this bizarre mystery has forced scientists to rethink some of the deepest ideas about how stars live and die. To understand how impossible this is, imagine the life of a normal star. A star burns because it fuses hydrogen into helium at its core. This fusion creates pressure that pushes outward, holding back gravity. For billions of years, this balance keeps the star alive. But eventually, the hydrogen runs out. The core contracts, the outer layers expand, and the star becomes a red giant. Depending on its mass, it will end either in a peaceful collapse into a white dwarf or in a violent supernova explosion that scatters heavy elements across the universe. This process is so well understood that scientists can predict the future of almost every star, including our sun. So when researchers discovered stars that had already reached their theoretical end but somehow continued shining, they were stunned. One of the earliest examples of such a star was found in a distant galaxy, shining with unusual consistency despite showing signs that it should have collapsed ages ago. Scientists observed its brightness over years and noticed something extraordinary. Instead of dimming or exploding, it pulsed with energy again and again as if rejuvenating itself. They called it a zombie star, not because it was dead, but because it seemed to have crossed the boundary between life and death and then returned. Later, even more bizarre stars were found, stars that had exploded in supernovae multiple times. This shouldn't be possible. A supernova is the final event in a massive star's life. Once it explodes, the star's core either collapses into a black hole or becomes a neutron star. Yet in 2014, astronomers witnessed a star called IPTF-14HLS explode in a giant supernova, and then explode again and again over the next few years. This single star released energy that matched several supernovae combined. Scientists were completely shocked. A star that dies multiple times? Nothing in our textbooks covers this. To make sense of this, theories emerged, some suggesting that these stars had unusual compositions, others proposing exotic internal physics that allowed them to rebuild themselves after each explosion. But none of these explanations fully fit the data. The star refused to behave like anything we had ever seen. As observations continued, more examples began to appear. Some stars seemed to resist collapse, clinging to life even after exhausting their nuclear fuel. Others shone far brighter than expected, as if tapping into some hidden power source. A few appeared to reverse their aging process, shrinking and stabilizing instead of expanding into giants. One even regained mass, possibly absorbing surrounding material to reignite itself. These behaviors were unheard of in standard models of stellar evolution. The more astronomers studied these stars, the more it became clear that something deeper was happening. Perhaps our understanding of gravity inside ultradense objects is incomplete. Perhaps there are unknown forces or particles playing a role. Or perhaps the internal structures of stars are more complex than our simulations can currently reproduce. One idea suggests that these stars might contain extremely strong magnetic fields that counteract collapse. Magnetars, for example, are neutron stars with magnetic fields trillions of times stronger than Earth's. But even magnetars eventually fade. These death-defying stars, however, seem to resist decay indefinitely. Another idea suggests that dark matter, the invisible substance making up most of the universe, might accumulate inside some stars. If dark matter interacts differently with gravity, it could help stabilize a star long past its expected death. This would mean that stars refusing to die might actually be revealing secrets about dark matter itself, something humanity has been trying to understand for decades. There is also a hypothesis involving quark stars, objects so dense that their matter collapses beyond neutrons into quarks. These stars could resist collapse longer than any normal neutron star, creating an illusion that they refuse to die. But this doesn't fully explain the repeated explosions or the rejuvenation-like behavior seen in some cases. A wilder theory suggests that some of these stars might be tapping into energy from extra dimensions or quantum processes we do not yet understand. Although this sounds speculative, the universe often forces us to consider possibilities that once seemed impossible. Black holes themselves were once thought absurd. So were gravitational waves. Now they are proven realities. Perhaps the most intriguing idea is that some stars may be experiencing a type of internal instability that cycles between collapse and expansion, like a dying heart that somehow keeps beating. This could allow a star to explode partially without fully destroying itself, surviving event after event. But again, this behavior does not match anything in our physics textbooks. The mystery deepens when we consider the implications. If stars can survive beyond their predicted lifespan, then maybe our understanding of the universe's age and evolution needs revision. Supernovae are used to measure cosmic expansion. If some of these events behave unpredictably, it could affect our calculations of the universe's size, age, and fate. Not only that, but the elements created in these long-lived stars could be different. Heavy elements like gold, uranium, and platinum form during extreme stellar deaths. If some stars die differently or refuse to die at all, the distribution of elements in galaxies could be influenced in ways we never realized. It could even mean that some rare elements on Earth exist only because such stars behaved strangely billions of years ago. Then there is the philosophical side of the mystery. For centuries, humans believed the heavens followed perfect laws. But the cosmos keeps surprising us. Every time we think we understand the rules, the universe breaks them. These stars are reminders that nature is far more creative, unpredictable, and mysterious than our theories can capture. Imagine looking at a star through a telescope, knowing it should have died thousands of years ago. Yet there it is, still glowing, still resisting, still rewriting the laws of existence. It challenges not only astrophysics but the very idea of inevitability. Stars have always been symbols of cycles, birth, life, death. But now, some of them are living outside this cycle, stretching the boundaries of possibility. What does it mean for the fate of our own sun? Could a small percentage of stars avoid death through unknown processes? Could new physics emerge that allows certain stars to persist indefinitely? And if the universe contains stars that refuse to die, what else might it be hiding? Perhaps these stars are windows into new physics waiting to be discovered. Perhaps they are keys to understanding dark matter, quantum gravity, or unknown cosmic forces. Or perhaps they are simply rare natural phenomena that remind us how incomplete our knowledge still is. One thing is certain. These stars are not just anomalies. They are messages from the cosmos, telling us that the universe has chapters we have not yet read, secrets we have not yet unlocked, and rules we have not yet understood. Scientists continue to monitor them, watching every flicker, every pulse, every strange behavior. Each new observation adds a piece to the puzzle, but also raises new questions, deepening the mystery. And maybe this is what makes the universe so endlessly fascinating. Not the things we already understand, but the things that challenge us. The things that defy explanation. The things that force us to rewrite the boundaries of science. These stars that refuse to die remind us that in the grand cosmic story, nothing is ever final. Not life, not death, not even the destiny of a star. And somewhere, across billions of light years, these impossible beacons continue to burn, lighting up the darkness with a message older than time. The universe is full of wonders we have yet to imagine.